Okay, so let's continue this time. So here, this time we'll continue the proof of the lifting theorem. Okay, so here we are trying to show that okay, so we are trying to show that this H, okay, so we're going to show that H is continuous on the connected subset C minus epsilon, comma C cross R minus epsilon, comma R plus epsilon intersect 0, 1 of D. Okay. Okay, so okay. So okay. Oh, I see. Okay. So because okay, so Okay, so that shows that this H is continuous on the connected subset. Okay. So now what's next? Uh, hence, hence the image of the set must be contained in some open set U1 that is gamma mass homeomorphically onto U. Okay, so remember that we are okay. So remember we are assuming that this HD is contained in some evenly covered oversized U, right? This is what this is what we so yeah, so we take the epsilon. Wait. Okay, let me write down the original wait. So here originally says if epsilon bigger than 0 is sufficiently small and this B is being defined as C minus epsilon comma C plus epsilon intersect AB cross r minus epsilon, comma r plus epsilon intersect 0, 1. Then HD is contained in some evenly covered open set U. Okay. I think what is needed here is, yeah, you take the epsilon small so that this D is defined to be the thing I just said. The image under H of that D is contained in some evenly covered open set U. Okay. Okay. So suppose that okay, so let's see why this image must be contained in some open set U1 that box. Okay, so we know that so no, we know that this H from okay. We know that this H from this D to we know that this H is certainly continuous, right? And then so we know that this H hat is like the lifting of this H, right? So okay. Yeah, maybe I need a wait. So why this set must be contained in some open set U1? Okay, so now what happens? So we know that the H is continuous, and then okay, we know that this H hat is like the lift of this thing. Okay, so each curve, each hat is like the lift of this H, right? So and then we know that this H hat is continuous on the connected subset. See, okay, it's continuous on the connected subset. Continuous means that basically it's continuous. Okay. Okay, okay, I see. Because this set is connected, I think that's the key. Okay, so I think the thing is that if you have okay, so basically you have, okay, so here you have this set. Let's see, so there's a point C. So we are assuming that this C is bigger than A, right? And then we can choose this sigma minus epsilon so that this is like there, right? So this is like there. This is like C minus epsilon. This is C, and then this is like A. Then this is like B, and then you take that. You take this open-ended and closed-ended interval, and then you make a cross. Okay. So it will be R minus epsilon, R plus epsilon. So it will be like this kind of case. Okay. So okay. So now this set is mapped by H. Okay. And then it maps inside the is that what? Oh, okay. H is continued on the connected subset is of D. Okay. Okay, we know that this HD is contained in U, right? So therefore this set being a subset of D is also contained in this U, right? So this is set. Okay, let's call this S. This is H of X. And then okay. So we want to show that this H hat is continuous. We know that this H hat is continuous. So we want to show that the image of this set must be contained in some open set U1. Okay, so because we know that this U is even covered, right? And then okay, I see. Okay. So remember that this S doesn't contain the point because it's open open at this. Yeah, it doesn't contain the C. Okay. So basically, we see that this is like CR as our as the point we defined before. Okay. So so this HS should also contain this CR, right? Sorry, the image of HCR. The image H sigma R. Okay. So it sits outside this HS. Okay. Okay. So now the thing is, but this HCR definitely lies inside this U, right? So for this U, what we can do is that we can find a so we can find a U, so here that so basically okay. 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 So so since okay. So since this U is even covered, there is a U1 in this covering space X hat. Open set, okay. Open. Such that. And also remember this H hat is like the lift, okay. And then with that with that this H hat of this CR, which is contained in this U1 and this map, let's see, is a homomorphism. So homeomorphism. Okay. Okay, so now we want to show that this H so we want to show that the image of this. Okay, so now we define the U1. So we want to show that the image of this set must be contained in some open set U1. The image of this set, what is, okay, on the H hat, right? The image of this set on the H hat must be contained in this U1. Okay, so why would this image, okay, so know that. So, chat is what I got. Okay. Okay, I think okay. So okay. Okay, so let's try to show this fact. Okay, let's try to show this fact. So uh, so by the definition of lifting, we know that
and then so therefore okay. 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 Yeah, so the thing is that, yes, so since we have a complete, yeah, so because this h hat is the h hat is being defined as you lift each pass, yeah, yeah, so you lift each path from this h to the, yes, because for each path in the covered space, once you fix the, once you fix what? Once you fix the starting point. Let me see the. Yeah. So once you fix the starting point, then there is a unique lifting. Okay. Okay. Yeah. So yeah, so we define this H as to be the unique lifting, the family of unique lifting of this H. Sorry, this H has to be the family of unique lifting. Yeah, of H. Okay, with the same with the same starting point being fixed. So okay, so now yeah. Okay, so therefore we have, because it's the lifting, so we have this projection, right? So yeah, so because it's the lifting, so we have, okay, yeah, so we have the we have this relation for each oh yeah, because of the definition, yeah. And then therefore yeah, so this is contained in gamma inverse U. And then we know that this HS is contained in, because this U is an evenly covered neighborhood, so this H is contained in this discrete union. Okay. Okay, so yeah, so I want to say that because we know that this curve, okay, so okay, so since yeah, so the idea is that, so we want to, so yeah, so we want to show that, the idea is that because this is the family of curve, and then, so if I pick just one of them, then it will be just a single path. And then, so I know that this path is continuous, right? So therefore, if I do the lifting, then this path, yeah, being one of the elements of this H, the lifting of this path is defined to be this H hat CR, right? So this is the lifting of this physical path. So let me write. Yeah, okay. Never mind. This is the definition. So, yeah. So this path is being defined to be, I think is, let me see the definition. Okay. Okay. So here this R is like the index for the variation. So HR. Oh, hello. Oh, sorry. Yeah, I'm fully finished. Sorry. Actually, 11. I'll finish until 11.
No, you're fine. I'm looking for Mercedes. I'm looking for.
Oh, okay. I think she is somewhere like, yeah. Okay, sorry. So, yeah. Yeah, so the lifting of this curve upstairs gives you a curve, yeah, so, okay. I want to say that, okay, I see, okay. Since this curve, because we know that this curve is continuous, okay. Or maybe, anyway, okay. So, and, oh, I think it's H hat, right? Yeah, yes, it's hat, okay. Yeah, we show that, yeah, it's continuous on this segment so, and then, it's, U1 is not empty because if you plug in, yeah, it's not empty, and then this implies this H hat are, oh, sorry. Let me use C minus epsilon, C plus epsilon. Okay. Yeah, so therefore it's containing U1. Okay, it's containing U1 by a similar argument we discussed before. Basically, yeah, and then yeah, so basically, yeah, okay, then okay, so now this implies what? This implies yeah, maybe okay. So this implies that this H hat of X intersect okay, this U1 is not empty, and since yeah, since this P compose it since okay, since this gamma composite H hat, yeah, since H hat is in this U, right? Yeah, so therefore we get yeah. What? Okay. All right. So we show that. Okay. So let's see now what happened. Again, applying the local inverse we get a continuous lifting of H hat of H restricted on D that agrees with H hat along the set